Okay, let's talk about centroids. So a centroid, well, let's put it in black. Is okay. First part is it's a point where the object would rotate about. It's always the point that gravity acts on, and that's called the center of gravity. You can think of a centroid as a balance point where the body the balance point where the body would come to rest if there was no motion. All right, so think of it like this. Here's a squiggly object, and you'd like to say it's right there in the center. Well, we don't know. In order to know that, we got to draw some lines through this thing and find where they all intersect, and that would become a center. It could be as simple as using a square. See, did I draw that right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Being a square. And we do the diagonals. That's not a diagonal. It's a better one. That would be the centroid. So if we'll use this square for a minute. If we have a height h and we have a width w, the centroid would be w over 2 and h over 2 would be our location of the centroid if this is 0, 0. Okay, it's that relatively simple to make that become part of that. Now let's try something a little bit different. We have a triangle, and we want to find the centroid of a triangle. It's going to be one-third the base and it would be one-third the height. Okay, so this would be our base, and we would have this as our h for height. Okay, circles would just be your dead center, so wherever the radius is. If it's a parallelogram, it's still based on components of different things. So we'll take different geometric shapes here. So we know we'd have a centroid there, and we'd have a centroid there, and we get a centroid there. So when you add all these shapes up in their centroids, you're going to find out that it's probably right there. And we're going to talk about that in the next video here, so that you get some understanding of what how to create different shapes and find these things. But it's really easy. So let's pick one with some numbers here for a minute. Let's pick a well, let's do this. Let's do a triangle. All right. And we already know it's one-third and one-third. So let's give this a 5, and this one a 4. Okay. And we're going to go one-third the height is equal to one-third times 5. And we're going to get an answer. And of course, I didn't bring a calculator, and 5/3 is it's going to be 1.67 from the bottom. Okay, and 1/3 the base, actually a little b, is 1.33 from the right side in this particular triangle. Okay, so it'll always be located someplace in there. All right, I think that's simple enough demonstration of what a centroid is, where it exists, and as long as we're here, why does it matter? Well, okay, so project forward. Strength of materials. And we're going to get a stress equation that has a moment, a centroid, and a moment of inertia. And that'll be for the bending equation. So that's our bending stress. That's a good place to know why we need to know this. Okay, so the interesting thing is shapes for beams don't always come in nice straight patterns. Okay, but I'll leave that there for another video.